Hi, I'm Rainer, and this week we're going to do a problem that involves a cylinder rolling on a table which is connected by a massless frictionless pulley to a block that's hanging off the table. And what we want to do is we want to find the tension in this rope, and we want to find the acceleration of this block going downwards. So we've got a lot going on in this problem. We've got some rolling, we've got some moving, and we've got some more moving. So I want to do a bunch of equations to describe all of these things. So the first thing I want to do is pick some axes, and I want to make these axes consistent with the motion. So I'm going to guess pretty wisely that this thing is going to move down and to the right. And I know if it moves down, I'm going to go ahead and call that positive. I'll call that the positive y direction for the block. If it moves to the right, I'll call that positive. I'll call that positive x direction. And then if it rolls that way, it has to roll this way. So I'm going to make that my positive counter, or my positive clockwise rotational direction. So at this point, we can go ahead and start making some equations. So I'm not going to draw out free body diagrams, but you can see that the force is acting on these things. So on the mass of the block, let's go ahead and start there. So let's say the sum of forces in the y direction on the block, we call it downwards positive. We know we have a weight force downwards. So I'm going to say mass of block times gravity. And we have a tension pulling upwards from the rope. And we know, as a side note, that the tension here equals the tension here because this pulley is frictionless and massless. So I'm going to say the weight minus the tension, and that's going to equal the mass of the block times the acceleration of the block. So next, we can also do the exact same thing, but for this cylinder in the x direction. So we know that there's a static friction force pushing to the left on it, which is causing it to roll in the correct way. And we know there's a tension force pulling to the right on it. So I'll say the sum of forces in the x on the cylinder equals the tension in the rope to the right, which is positive, minus the static friction force, which is to the left. And I'm going to say that equals mass of the cylinder times acceleration of the cylinder, which I know is the same as the acceleration of the block. And then finally, we've got one more equation we can make, and that's the sum of torques on this cylinder. So I notice that the friction force is the only thing causing a torque. The weight of this acts at the center. The normal acts in a parallel direction to the axis vector, and then the tension acts at the very center. So this friction is acting at a distance from the axis, and I did choose my axis to be the center of the cylinder. It's acting at a distance of the radius of the cylinder away, and it's already perpendicular, so I won't worry about throwing in signs of anything. So I'm going to say that the torque due to this thing is in the positive direction, and it's equal to r of the cylinder times the friction force. So I'll say the sum of torques on the cylinder equals r of the cylinder times the friction force. And that, since it's our only one, is going to sum up to I times alpha. Now I know I for a cylinder is just 1/2 mass of cylinder, r of cylinder squared. And then I know that alpha, in this case, I'll apply the rolling condition and say that alpha is a over r of the cylinder, where this a is the same as these other two a's. So at this point, we've now got 3 equations and 3 unknowns. We don't know a, we don't know t, and we don't know f. So our goal at this point, since we're looking for t and a, we're going to get rid of friction through substitution and generate 2 equations and 2 unknowns for tension and acceleration. And it's all algebra at this point, so I'll leave that as an exercise to you.